Lesson 2.4, Solving Equations with Variables on Both Sides. The objective here is to solve equations that have variables on both sides of the equation. Some vocab. The only vocab word here is the word identity. An equation that is true for every possible value of the variable. For example, x plus 1 equals x plus 1 is an identity. An equation has no solution if there is no value of the variable that makes the equation true. For example, x plus 1 equals x plus 2 has no solution. Solving equations with variables on both sides. To solve equations with variables on both sides, you can use the properties of equality and inverse operations to write a series of simpler equivalent equations. Problem 1. What is the solution of 5x plus 2 equals 2x plus 14? What I like to tell my students is you want to get all of the letters or the variables on the left-hand side of that equal sign, and you want all of the constant or the numbers to the right-hand side. So, if we draw our line where the equal sign is, we want letters to the left, and we want numbers on the right-hand side. So take care of one of those first. We see that there are letters and numbers on both sides of this equal sign. So in step 1, we're going to move all of the terms with a variable or all of the letters to one side of the equation. So we're going to move it to the left-hand side. That means we have to move this positive 2x. So we are going to subtract 2x from both sides. And when we simplify that, it becomes 3x plus 2 equals 14 because these cancel out. Now this becomes a two-step problem. Subtract 2 from both sides, you're moving the numbers to the right. 3x equals 12. Simplify, solve for the variable using inverse operations. The opposite of multiplication is division. Divide both sides by 3 and you get x equals 4. Next problem. What is the solution of 2 times 5x minus 1 equals 3 times x plus 11? Again, draw the line where the equal sign is. Now here we have to do a little bit of extra. We have these parentheses. We learned in previous lessons that to get rid of parentheses, we use the distributive property. Now here we have to do it twice. So that's what we do in step 1. When we distribute, we get 10x minus 2 equals 3x plus 33. Now this is your new equation. Draw your line where the equal sign is, and now it's just like the previous slide. Letters to the left, numbers to the right. So here we're going to move again all the terms with variables to one side of the equation. We have to get rid of this positive 3x, so we're going to subtract 3x from both sides. When we simplify, we get 7x minus 2 equals 33, and again this becomes a two-step equation. Add 2 to both sides, and then divide by 7, and you get x equals 5. Now, here we have identities and equations with no solution. Problem 4. What is the solution of each equation? So the first equation we have is 10x plus 12 equals 2 times 5x plus 6. First off, we want to get rid of these parentheses, so we're going to distribute. So 10x plus 12 equals 10x plus 12. Now ask yourself, did I just say the same thing twice? If the answer is yes, as in this case, this will always be true. Therefore, there are infinitely many solutions of the equation. The original equation is an identity. So if you have the same thing on the left as the right, then the equation is an identity. The next equation, 9m minus 4 equals negative 3m plus 5 plus 12m. First thing you want to do is you want to combine like terms on the right-hand side. Negative 3m plus 12m is positive 9m. So now we have 9m minus 4 equals 9m plus 5. So if we bring all the letters to the left-hand side, we're going to subtract 9m from each side. Well, guess what? 9m minus 9m is 0 on both sides, so all you're left with is negative 4 equals 5. That is never true. They don't equal each other, so therefore the original equation has no solution. And that's the difference between an identity and no solution. So let's do some sample problems here. Okay, I'm going to choose to do number 2. I want you guys to give number 1 a try on your own. Remember, draw the vertical line where the equal sign is. There's no distribution here. Just bring the letters to the left and the numbers to the right. One step at a time. So let's look at number 2. First, we're going to distribute just like we did before. So we have 8y plus 4 equals 2y minus 26. Now, like I just said, you want to do one thing at a time. Don't try to move everything all at once. Take your time. So first thing we're going to do, this is a positive 2y. We're going to subtract, and the like term on the left-hand side is this 8y, so I'm going to write it directly underneath. 8y minus 2y is 6y. That's the only operation we're doing, and we are just bringing down all of our terms. Remember that this is 8, now negative 26. Now we're going to bring the numbers to the right. We're going to subtract 4. 6y equals negative 26 minus 4 is negative 30. And now our final step is to just simply divide by 6. Positive 6. So y is equal to negative 5. And again, you can always check your answer by substituting your solution back into the original equation. Now let's see, these are two sample problems just like we had before of which one is an identity and which one has no solution. So let's look at number 1. It says 3 times 4b minus 2 equals negative 6 plus 12b. So let's distribute first. We have 12b minus 6 equals negative 6 plus 12b. Now, although these might not look identical, if we rewrite it, okay, this is a positive 12b. Is there a positive 12b over here? Yes, right here. So we can actually switch these two terms to look at it a different way. So we have 12b minus 6 equals, and if we switch those two, it's still a positive 12b, and negative 6 now becomes minus 6. So this would be an identity. Same thing on both sides of that equal sign. Number 2, we have to distribute again. 2x plus 7 equals negative 1 times 3 minus 2x. So negative 1 times 3 is negative 3. And negative 1, be careful here, times negative 2x is positive 2x. So let's bring again all the numbers to the right. So we're going to, all the letters to the left. So again, we're going to subtract 2x from both sides. 2x minus 2x is 0. 2x minus 2x is 0. So all we have to do now is bring down the other terms. We have positive 7 equals negative 3. This is not true. Therefore, this equation has no solution. And this last slide, this is a great summary. It comes from your textbook about how to solve equations, whether they're one-step, two-step, multi-step, variables on both sides. All right, 5 easy steps. You do not necessarily always have to do step 5, checking your solution, but it's there for you. Okay, so step 1, use the distributive property to remove any grouping symbols, such as parentheses. Use properties of equality to clear decimals and fractions, just like we did in previous lessons. Step 2, combine like terms on each side of the equation. Remember to draw your vertical line down that equal sign so you are balancing it out. Step 3, use the properties of equality to get the variable terms on one side of the equation and the constants on the others. Remember, letters on the left and numbers on the right. And step 4, use the properties of equality to solve for the variable. Once you get your solution, you can always check your solution in the original equation by substituting it back in. I would write this down somewhere so that you have it and you always remember it. We'll talk more about this lesson and solving equations tomorrow. See you later.